All right, so let's get this lecture underway. I have the course website open, but I don't think I need to talk about this at all, right? Is there anything new? I want to think, because I released a homework today in 312 and I forgot to mention it. I forgot to post it and mention it in lecture, so I want to make sure I don't miss anything here. I don't think there's anything new, right? Okay. Let's get some slides open. I don't have much for slides today. Today's going to be mostly a live coding day, so I'm going to give myself some problems to work on, and then I'm going to work through them and explain my thought process as I'm going through these solutions. I try to do this as often as I can in lecture after we have the content out there. Yeah, I'm in chat. Jesse Lee Hartloff. So I try to get the concepts out there, and then once all the concepts are out, I'll spend any extra time that I have giving examples in the code. So that's what we're going to do today, and these are usually interactive lectures, Friday live coding, and they land on Fridays. They're usually at the very least the last Friday of a learning objective, and like this, we got one in the middle too, one of these middle Fridays. So it'll be interactive. I'll be watching chat as much as I can as I'm coding. If you want me to slow down and explain something I did, just shout it out in chat. Let me know. We can do this interactive. I'm doing examples to show you examples of applying what we've learned over the past 2 weeks. That's the whole point of this. So if you have questions about anything I'm doing, just stop me, slow me down, let me know. The lecture question for today, this big cities. So we're in the cities.csv file again, and we want to find out for a given country, a given region in a country, tell me all of the big cities by some minimum population that we give. So this method takes a country in a region and returns a map of takes a country, a region, and the minimum population, and returns a map of all the cities in this region that have a population at least this minimum population, and maps their names to their population. That's not right. I'm mixing up. Sorry about that. I'm mixing up learning lecture objective 3 and 4. This takes a country and a region, a minimum population, and returns just a list of the city names of that population, not a map of names to population. A list of the city names, just the city names, that have at least this population, this equal to or greater than. All right. Yeah, I always know. I know everything. Don't test me. So with that in mind, so the big thing here, and the theme that we'll talk about throughout this lecture, or at least for my second example, I have 2 examples that I'm prepared to go through. The second example is testing a list in our unit tests. That's something we haven't done yet. So this question is very similar to lecture objective 3, but lecture objective 3 returned a map. To compare maps, we used equal, and it says, do these maps have the same key value pairs? With a list, we have a little bit extra to do because list, the order matters. In a map, we got away with equal outright because the order doesn't matter. So as long as they contain the same key value pairs. But now order is going to matter because we have lists. So that's something we want to think about as we get to that second example, especially. Yeah, only the city names, a list of strings that are the city names. All right, so with that, yeah, no population in the return. I misspoke with that. I was mixing up the 2 lecture objectives. Just a list of the city names. So I have 2 examples that I want to go through. I'm going to give the problem statement, and I'm going to work through this as though it were a lecture question. We don't even have lecture questions this semester, but as though it were an isolated question that I need to complete and submit to Autolab with testing. So for the first one, I want to write a method named isAnagram that's going to take 2 strings and tell me if those 2 strings are anagrams of each other. For this, we're going to ignore case and spaces. And an anagram means that you can rearrange the letters of one of the strings and form the other string. And we're going to ignore case and white space. So for example, if the input is astronomer and moon starer, this moon starer, it's all the same exact letters. We have different capitalization and we have a space in here. We have different spacing, but they contain all of the same characters of each other. So my method for this example should return true, just to get an idea of what we're trying to do here. And then write a test suite to test this functionality. I'm going to solve this thing live. So let's start some live coding, our first live coding lecture. Which I always like these lectures. They're more open-ended, and I get to interact with y'all a bit more. So to write this, I'm going to do something what we call test-driven development. I know I say here's the functionality and write tests for it, but what I'm actually going to do is write the tests first. And this is a recommended way. I'm a little hesitant to just outright recommend this, but a lot of people do recommend this. There are definitely pros to doing it this way. And for this class, I probably would recommend it just outright. But what we want to do is write our test cases first. So let's start writing some test cases. I'm going to start with the test case. Bear with me 1 second. So I cut and paste that because I didn't feel like typing it all out. This test case is anagram, astronomer, and moon stare. So first, I'm going to get errors right away because I don't have a method named is anagram. And even with test-driven development where we're writing our tests first, I will go to the code and at least write the header of the method. Now for the handout code for Pale Blue Dot, I give you all the headers so you can go right into test-driven development, writing your tests first. But I have to write my method. So I want a method named is... Oh my goodness. The worst part about this is I'm terrible at typing on stream. And I always end up looking at my keyboard too. So this method takes two strings and returns a Boolean whether or not these two strings are anagrams of each other. So we want to return a Boolean given these two strings. And I'm going to give it a default return value. You see this in the handout code that I gave you. I'll always give some default return value because if I don't, we get errors and then you can't run anything until you add some return value for each method. So for this method, I'm saying, hey, Scala, this method is going to return a Boolean. And then Scala's saying, hey, you told me you were going to return a Boolean, but you didn't return anything. You returned nothing, which we call unit in Scala. So since this isn't returning anything, Scala's going to give an error and said, hey, you broke your promise. You told me you were giving me a Boolean and you gave me nothing. So I always add a default value. We can do false or true for this example. Some default value just to shut that error up so we don't have to see that error and we can actually start writing tests. And I do have a closing brace, but I set up the next question. If you're wondering why there's no closing brace here, just quickly. So is anagram, that's in the anagrams class, anagrams object. So we can say anagrams.is anagram. Oh boy. No, there should be no problems yet. There's no way. Is anagrams. Live coding. Anagrams. Oh, I see. So I do have an anagrams object in this repo. If you want to look at the second example we'll go through today, it's actually right here in objects, anagrams. So what was happening there is I was importing that anagrams object, which is not the one I want. I want to use the one in this package. So is anagram. There we go. So I can call my method. Yeah, I'm not doing assert yet. And when I do live coding, you'll often see that I don't code in order. I don't start at the top and just code right down. I'll code in the order of my thought process. So I know that I have to call my method, and I want to call it on this input because that's one of the sample test cases that I have, and I want to make sure that this is going to be true. So I know that has to happen in my code somewhere, and then I'll build the structure around that and then start refactoring and making it more organized. But just my personal style, I'll tend to code in the order of my thought process. So this should be true, but that's going to start being a mess. And of course, you are right. That is the next thing that I want to add is my assert. And I want to assert that that's going to be true. So I need to say that is going to be, that should return true. Now, we can start writing more test cases. Let me just slap an S. Sounds like a good test case. And let me just start adding different test cases that are just made up words, because I don't have too many anagrams on the top of my head right now. And I want to start mixing up the capitalization. And making sure that I'm testing a lot of things, a lot of different inputs. And we're going to get into that question of how much is enough here. And we're going to quickly get into a scenario where this code is going to be a mess. It's going to be a lot of cut and paste. So I'm going to start refactoring this right away and start putting my test cases in a data structure. And this gets to a question that was asked earlier, is I have two inputs. I want to create a map of the inputs to Booleans. Oh my goodness. To Boolean. And I want to create my test cases in some way. I want to say astronomer and moonstare is going to map to true. Fort laughed. I'll add that. Fort laugh. And I need these two inputs in, together in some way. So what I'm going to do is create a list of those two inputs. There are a lot of different ways to do this, and when we get to learning objective 2, we'll actually start building classes to be able to do this. We don't know about classes yet, so I'm going to use a list of string to be able to get my two inputs into these test cases. I'm going to give this a name. Test cases of type map of list of string to Boolean is going to map my inputs to my outputs. Since this returns Booleans, what we could do, I won't do it just because it only applies to several different problems. But since this is Booleans, we could have two lists of strings and store all of the expected true inputs in one list and all the expected false outputs in another list. But I'm just going to do it this way for now. List, oh my goodness. List of this with an S should be true. List true. Give me a bunch of these. Give me this. Give me this. Give me this. Delete all this. Oops. Actually, I want to keep one of those for reference. And then for half, why not both? So for my inputs to expected output in, oh my goodness, I keep hitting M, in my test cases. So for each input-output pair, I want to call isAnagrams on inputs.head, the first element in the list, and inputs of 1 or inputs.apply of 1, however we want to write that. We could also do of 0 here, but we'll get this yellow highlighting. IntelliJ is going to say, hey, you could replace that with .head, and it's gonna do that for us. And then equals expected output. Now I want some hint text so I get to know what happened here. If this fails, I'm going to keep this one simple and just say print out the inputs for me. Given the inputs, I can look in my map up here. I can figure out, okay, if inputs was this, that was supposed to be true. If that test case failed, then I know that my code returned false. So I don't have to check what the actual output was versus the expected output. I know based on the input, that's all the information I need to figure out what I need to know here. And here are our test cases. We can run these. We'll compile. And we fail. So we have some test cases. Did that fail? Oh, so I didn't write my last test case. Let's say object-oriented programming and pop are anagrams. So I got head of empty list. I was trying to call .head on an empty list. When you see that answer, when you see that. We don't need the exclamation point. The way this is worded, we only work with characters, so the 26 letters. So let's rerun this now that we don't have an error in our tests. And we passed these tests. Great, we passed our tests. Our code's great, right? Our code passed our tests, so our code must be correct. Right? Right? That's the point of testing, right? If testing says our code passed the test, then our code passed the test. So it must be right. How does OOP equal? Oh, yeah. I see what you're saying. This should be like OPPO. So the problem here is that we have really poor testing. So these are nothing wrong with these test cases. These are fine test cases. And I'll see students do this too. They'll take nice test cases like this and just keep writing more and more. I'll see students in office hours with 100 test cases sometimes. But they're doing really poor testing because they have a poor strategy going in. The big problem here is that every single one of my test cases is expected to return true. So since every test case is expected to return true, and my method just returns true, we're passing this test case. The screen's not frozen on my end. Just try refreshing it. So my method just returns true on any input. So it's always going to pass these test cases. So what we need are some test cases that we expect to return false, those negative test cases. So let me get some test cases that give us false. And now we got to get kind of creative. With the ones that return true, as long as we have some good looking anagrams, as long as we're testing the spaces and things like that. And speaking of, since spaces are supposed to be ignored, we can jack this up with as many spaces as we want. And that still needs to work. So that's a good test case because it's making sure that I'm really hitting those spaces the way I'm supposed to. So let's get some that return false. This one has an extra letter in the output. I want to make sure that I have some that are false that have the same number of letters. So let's get pop back in there. Let's get pop that all matches case. So this one matches the case. This is really close to being good, but the case is off. The case is good, but the letters are off. And this also has duplicate letters. So duplicate letters is something that's easy to mess up. I actually want to add that as a true. Like if I just have O. Like these are anagrams of each other, so that needs to return true as well. And let's get some more falses. Actually, let's get one more true in here. And I like to keep things organized, so I'm going to put this true with the rest of the trues. Oops. Oh, no. And let's get another false that does a similar thing. The empty string and something with just one character in it. And let's get some more false test cases that are really close. Charms. That actually worked. My typo actually worked in my favor there. Licky Charms and Charms Lucky. Those are not anagrams of each other. And this is looking pretty good. Like, I'm pretty happy with this test suite at this point. We got a good variety of test cases. We're testing a lot of different things. We make sure we have duplicate letters in there. That's a big thing to mess up. That's an easy one to mess up in this particular question, because you might just check, is every character in this string also in this string? And is every character in this string also in this string? Well, that's not going to hit the duplicates the way that you want. And actually, speaking of... Actually, this one does it pretty good. And let's get our OOO test case in here is a false test case as well. 4 O's versus 5 O's. So, and we have empty string. We have to make sure we define what happens there. Empty string is an anagram of itself and nothing else. Not A. So we have a pretty good test suite here. So this is what the thought we want to go through when we're writing these test cases is getting a nice variety of types of test cases. Not just a lot of test cases, but a good variety. We have our positive test cases. We have our negative test cases. And for each, we're testing a lot of different things that can go wrong. So when you have oatmeal squares are so good. Or oatmeal pies, actually, is what I'm thinking of, what I heard. It's got the frosting in the middle. So good. And we have negative test cases, and we're testing different things. So when you're writing test cases, you want to think about what could go wrong in your code. So in this, like I mentioned, duplicate letters, that's something that's easy to code incorrectly. It's easy to write code that's almost correct, but doesn't handle duplicate letters very well. The spaces, we of course have to account for spaces because that's part of our problem definition. Words that are really close to each other, things like that. So I'm happy with this test suite. We could always add more test cases, but I think we hit the major points here. So with this, I ran the test suite, so the green button on the top of my IntelliJ is going to run the test suite, which is nice because as I'm writing code, maybe I just want to change this to false. I can hit this button, run the last program that I ran, which is my test suite. So I can write in my code, not editing the test suite, but run the test suite very conveniently. That's where this button really comes in handy. Instead of clicking over, running this, I'm just going to use the button on the top of the screen, making sure that that's running my test suite. All right, code time. When it comes to testing, it is common to spend more time writing tests than writing your code. That's going to be true here. S1. I'm just going to write this really quick, and then I'll write it again in a different way. Does toList take parentheses? No, it doesn't. Oops. I'm going to claim that this is correct, that I just solved that problem. Do you believe me? Do you not? You know what? It shouldn't matter because I'm going to run my test suite. And if you're convinced that those tests are good, whoop, it's wrong. If you're convinced that those tests are good, then if this test suite passes my code, you should be convinced that the code is correct. If you're not convinced, write more tests. If you're not convinced that any code that passes your test suite has to be correct, then you don't believe that your tests are good enough. You should be writing more tests. So let's see what went wrong here. I need my hint text here. Astronomers and moon starers was incorrect, so I know I returned false on this one. Again, this is a map. Ordering doesn't matter, so this test will actually fail, but this test happened to be ran before that one. I know exactly what I did wrong here. Just something I forgot to do. Replace my spaces. Dot replace. Actually, I don't know if I will write this code again. Maybe after lecture, because I want to get on to the next one. Run my test suite again. And now I definitely expect this one to pass. So even if you don't know what I'm doing here, if you don't see everything that I did, I promise that that actually does tell if these two strings are anagrams of each other, ignoring case, ignoring spaces. And you should be convinced of that because you should be convinced of this test suite, that this test suite is testing this appropriately. And that's what we want to do with testing. When you write your test suite, it's going to be ran against your code. That should pass because you ran it before you submitted. My correct solution, you don't know what it is, but if your test suite passes, you should be convinced that it's correct. And likewise, if your test suite fails on my correct code, we know that your test suite has an error in it. And then my incorrect solutions. Each one of the incorrect solutions is going to be ran against your test suite. And if your test suite passes an incorrect solution, it means it's doing something. That incorrect solution is doing something that you didn't test for. So maybe the incorrect solution doesn't get the empty string right. Maybe that's what it does wrong, but it passes all your other test suite test cases, and you don't have this test case. Well, then you're going to pass an incorrect solution, and that's no good. Since there's questions about it, I'll quickly go through what I did here. So I'm taking the string, converted it to lowercase. I actually do want to talk about this a bit since you have to do it for your lecture questions, LO2 especially. I'm going to convert them both to lowercase. So there's this question of how do we compare two strings and ignore case? As some of you pointed out, there is a compare to ignore case. You can use that to compare if you want, if you're comfortable with that. What I recommend to make sure that you really know what's happening with those is call to lowercase on both of them. Now, no matter what case each of these strings were to begin with, I don't care what they were. I'm just going to convert all the characters to lowercase characters, and then compare them as lowercase characters. So when S1 is astronomers, I'm going to call astronomers.toLowercase, and it's going to lowercase this A. Moon stairs, it's going to lowercase the M and S, and just give me everything as lowercase letters. I'm going to replace all white space with nothing. I'm just going to remove all the white space. I'm going to convert the string to a list. This is going to give me a list of the characters of the string. And then I'm going to sort that list. So now, whatever the characters were, I'm going to sort them in order. And actually, let me print one of these out. I'll just print it to the screen. We won't get too fancy because I do want to get to the next example. So when I have this O, I'm going to end up with a list. That one's not interesting, is it? When I have astronomers, I'm toLowercasing, removing white space, converting the character sequence to a character list, and then sorting that list. So I'm going to get all of the letters, and only the letters, as lowercase letters, and sorted in alphabetical order. So once I do this, if those two lists are equal, then I know these are anagrams of each other. I don't have to do any checking. This handles duplicate letters. This handles spaces, uppercase, lowercase. Handles all the things in our problem statement. Handles empty list. Is replace like strip in Python? Not quite. So strip in Python will remove the leading and trailing white space. Replace is actually replace in Python. I'm replacing every instance of the space character with the empty string, which effectively removes all spaces. And sorts alphabetically. It actually sorts them by their ASCII values. Like if I don't do toLowercase. Yeah, we can write this code way more complicated. If we do toLowercase, that's a bad example. The uppercase letters are going to show up before all the lowercase letters. Because that's how their ASCII values are. So it's not strictly alphabetical. Especially can compact code in a hydraulic press. I feel like this one could be more compact, but that's not the goal here. Okay, what is the goal is to get to this next example. Actually, let me pause for a second. Are there any questions on that one? Is there an equivalent to Python iter tools for Scala? So every data structure in Scala, I don't know if this is what you're asking, but every data structure in Scala does have an iterator with it, and you can use it as you can get its iterator and then iterate over the data with that. You want to do like next and has next? Is that what you're getting at? But we could talk about that some other time. Is there supposed to be live coding in SRC for the examples? No, so this isn't in the repo, what I'm doing right now. I can add that example to the repo, but I'd have to do that. I'll do that during the chat and after lecture. I want to get through this next example. Would C++ example be more or less compact? I don't know. It depends who's developing. If I did a C++ example of that example, it'd probably be like 20 lines. But an experienced C++ dev could probably do it just as compact. Can you sort a string instead of converting it to a list? Probably, but I don't know for sure, so I didn't do it. But you might be able to do that. All right, so what we've learned from that, when we want to compare case-insensitive strings, a reminder, we've seen this before, but call toLowercase on each string. Now you have all lowercase letters. You don't care what case they were. They're all lowercase now. Compare them with equality. We can use a map to store test cases. Even when we have multiple inputs, we can still use a map, but our data structure gets a little more complex. We had a map of lists to Booleans in this case. So a little bit more stuff going on in that map, but we can still use a map of inputs to outputs. How much testing is enough? Well, the short answer is until you're satisfied. You should be satisfied. If you're satisfied with crappy testing, then Autolab's going to kick in and say, hey, look, you got to do some testing here, in this course anyway. But you need to convince yourself that any code that passes your test suite is absolutely correct code. That's the trick. That's what you want to get at the very least, by the time you graduate and go out there in the working world. You don't want to be releasing code that you're not confident that it's correct. You need to be convinced that it's correct. You do replace before two lowercase? Yes. Yeah, some of the ordering that I did there didn't really matter. But we did have to do replace and two lowercase before converting to a list, and then we can sort. Oh yeah, I don't know what the Scala equivalent for that would be, but I believe Scala has those things. Accumulate for sure. Permutations, I think. And using stuff like that, we could do it even quicker, especially this next example. So, how can you test code that you got from Stack Overflow and you don't understand? Yeah, that's kind of exactly the thing I don't. Those are the behaviors I want to break in this course if you have them already. You shouldn't have behaviors like that this early in your career, especially. Don't use code you don't understand. For one, you're not going to pass the interviews in this course if you do that. So let's do this again. Let's do another example. We're going to stick with anagrams, except now given an input string, return all the anagrams of that input and test it. Test the functionality. So let's tackle this one. Given a string, give me all the anagrams. And for this, I did start... IntelliJ. I did write the method. And this one I do have. I'm going to write it almost exactly, from memory, but almost exactly as it appears in the repo. Elsewhere. And I'll get this is anagrams and the test is anagrams in the repo later, after lecture. So with this one, I set up my test cases as well, just because I didn't want to be really repetitive in lecture and write the whole thing. Can we get a sub button? No. Sorry. Just real quick on that. Once there's a sub button, there's going to be pre-roll ads, and having ads on a lecture just seems horribly wrong. So you'll never see a sub button. So I have two inputs. The empty string is its only anagram. Actually, that should be... Yeah, we're going to define that as empty list. This could be, we could return the list of just empty string. Depends how we define the problem. I'm going to define it as the empty list. Yeah, only non-subs will get ads. So you have to sub to the channel to watch lecture without ads. No, I can't do that. So if we have... what was our word we were going with? OOP. I guess I'll stick with OOP. So all the anagrams of OOP, and we're not going to mess around with case today. We could combine those, but it's just going to be extra clutter. We've already made the point about case and capitalization. So OOP, OPO, and POO are going to be our three anagrams. I'm not going to do any really long ones. I will do OOO. I will do our O's. That is its only anagram. Let's do one with unique characters, 3 unique characters. I don't have one. Anybody got a FWASD? That's good. No, is that? I don't want to... I'm just going to do WAS. Just because I don't feel like typing a whole bunch. WAS should end up with 6. because watching me type out all of the anagrams of a longer word would be super boring content. And we need ones that start with AWS, Amazon, and ASW. So those are all the anagrams of was. Now, importantly, I've seen this already quite a bit this semester. Importantly, always create your test cases by hand. Do not use your code to create your test cases, because if you're using your code to create your test cases and then using your test cases to test your code, well, guess what? Your code's always going to pass. Your test cases are always going to pass your code because you're not testing anything. You haven't tested anything. You just wrote code and used that code to make test cases that you use to test it. And more often than not, you're going to submit to Autolab and you're going to get your test cases are failed my correct solution, because your test cases are just completely ass broken because your code was broken, but there's no way for you to know that, and you're completely defeating the purpose of testing. Your tests aren't telling you anything if you use your own code to generate your test cases. So when you're generating your test cases, always create them by hand in some way that you can absolutely verify that those test cases are correct. For the cities questions, go through that CSV and pull out some countries, preferably countries with very few cities, and pull out some test cases from there that you know are correct, and then run your code against it to make sure they're correct. We'll talk about that a little bit more come Monday. For the greater circle distance question, we have an external tool that we're going to use to generate test cases. But here, I made all these by hand. I didn't run my code to figure out if they were correct or not. Anagrams. And here's the big thing. The big takeaway from this one is I'm going to call my anagrams method on the input of these test cases, and I'm going to get an output list that I want to compare to the output from this map. When I compare these two lists, if I do dot equals, what Scala is going to do is compare these lists and make sure they have the same values and in the same order. In the same order. So that means when I just wrote the order of these anagrams of was, I was just writing them as I thought of them. There's no particular order here. The order's not important to me when I wrote this test case, but Scala, when we compare these lists with equal, order is critically important, which means this test case will only pass on this test. This test will only pass on this code. This code will only pass on this test case if it returns the anagrams in the exact order in which I wrote them here, which is highly unlikely. It'd just be pure chance that we're going to get the same exact order with those. So what we do when we're comparing lists, when we don't care about the order, we're going to sort both lists. I'm going to sort whatever anagrams gives me, whatever it is, whether it's your code, whether it's my correct code, whether it's my incorrect code, whatever, wherever we're getting this from, in whatever order it gives us these values in, we're going to sort those values. We're also going to sort, unless you're really careful and you make sure all these are in sorted order, which I don't recommend, just slap or even if you do, it's fine if you do that, but also sort it here just in case you messed up some order somewhere. Sort your outputs as well. So now, if this contains all of the same values as this, since we're sorting both lists, if they contain the same values, we're going to pass this test case. All right, and now a bit of a speed run. I'm going to write some code similar to what I did before, but with a much more complicated method. I'm going to write some code. I'm going to claim that it solves the anagrams problem, and then we're going to run the test cases and find out. Well, let's run the test cases first to queue up my button on the top. And let's code this thing. Let's see. So I want to say if the input is the empty string, I want to return an empty list. Else if, and you're not expected to understand what I'm doing here. If input dot length equals 1, So if I have an input of length 1, I want to return a list containing only that input. If I have an input of one character, it is its only anagram, and we're done. Else, what I want to do is iterate over the characters of this string. So for index in input dot indices, if I could spell, it'd be more impressive. In indices, get the character at that index. And this is actually a char. Input. Can I just do of here? I think I can just do that, right? Yeah. And then I want to get this input string, but with that character removed. So I'm going to do val new string, and I've written this method, once a semester at least for the past few semesters. So this one's fresh in my brain. Input dot substring, which is going to give me a substring of this string from 0 to I, those indices, and substring excludes the endpoint. And then input that substring I plus 1 to input, input dot length. So that gives me a string with that character removed. Now what I want to do is some super duper magic. The anagrams of new string as a list of strings equals anagrams of new string. So instead of computing the anagrams of this new string, I'm just going to call anagrams. I mean, anagrams is a method we're writing that finds all the anagrams of a string, right? So I'm just going to call anagrams and defer to the method that I'm currently writing to actually do the work for me. So I have all the anagrams of this new string. Where'd my output go? I want this. I want this stuff inside this else. And I want to add all these to, so for and anagrams of new string. So for each anagram of that new string, if the output list does not contain Anna, output plus equals Anna. Oops. New anagram of string. I forgot to add the letter that I pulled out. So Anna appended to the character that I pulled out. So I'm going to re-add in that character that I removed earlier. Add that into these anagrams. So I'm going to get all the anagrams of the string with that character removed and add that character to all of those anagrams and do this for each character in the string. That should give me all of the anagrams of this original string. And if output does not contain new anagram, because I want to make sure I avoid duplicates, plus equals add new anagram to the output list. So you're not expected to know that. The purpose of that is to make your head spin a little bit, because when I go to test anagrams, you should be convinced that if these test cases, if you're happy with these test cases, and these test cases pass on that code, then you should be happy with that code. Oops, that's test is anagram. Test anagram. And I do have an error. Wrong syntax. I was thinking it was a map. And my tests pass. So with this testing, since we're running this test suite and you're happy with these test cases, we could of course have more test cases here. But we're testing a good variety of things. The empty string, a string with one character, a string with a duplicate letter, a string with a lot of duplicate letters, and a string with all unique letters. So we're doing a bit of testing here. And since this code passes that testing, even though this should look like magic the way this actually worked with what we call recursion here, this is passing the test and we should be happy with that. And just for good measure, just to prove that this is doing something, if we don't remove the duplicates and rerun our tests, we will see our testing fail. And we're failing on, so this was the first failing test case that ran. This is what we returned. Every one of these anagrams is in there twice, but we were expecting all the anagrams to only be in there once. So this code is doing what it's supposed to. And for my taste, I always like to see my test cases fail. I'll intentionally break code and make sure that it fails, just to make sure that the test is doing what it's supposed to be doing. Is always a good practice.